great bus tour yesterday. We visited this house and we visited a bunch of houses, and it was a great day for it. The Superhome annual bus tour. And we just thought we'd do a pop-up tour today because a lot of people, that sold out a couple of weeks ago and a lot of people wanted to come but they couldn't. So this was the last home that we visited on the bus tour. And there's 4 homes that were completed and 3 under construction. This was obviously one of the under construction ones. So it's actually really good to see homes at this stage so you can see how they're built and how it's different to a normal home and what goes on behind the scenes. So we've got Dan Saunders here, obviously, who can talk about the building aspects. I'm just going to talk a little bit about the design first. My name's Burnett. I'm one of the designers. My wife, Shizuka Yasui, was a big part in this too. So we've worked together on most of our jobs. She's a Japanese architect. So it's a kind of Japiwi collab. This is a Superhome. In terms of the Superhome certification standards, you get welcome to take one of these, but there's base, better and best. Base being the minimum standard, which we think is healthy for people and healthy for the planet. And then better or best depending on your budget. So this would be best. And there's different criteria for energy use and air tightness and those things that maybe Dan is going to talk about when we talk about the construction. Dan and I met the clients, Andrew and Laurel, through a previous Superhome tour, and they're actually just living next door. So, they saw this site. There was an earthquake-damaged house here. It was completely munted, so it was needing to be replaced, and they picked up the site from the previous owner. But it was good because we could see, like this house, it pretty much took up most of the site, so we could see what the view was like before we designed it, and it's really designed for the view. For sun and the view, so north is that way. And because we're really interested in protecting the house from overheating, we've got this big 2-metre overhang here, and right around actually. So there's going to be really good shading, and this hole that behind you here, that's going to have louvers, so you can open that up to let the sun in, or close it down if you want shade or protection from the rain and things. And it's a nice thing to have a sheltered area when you're up on a hill so that you're out of the wind too. So that's the idea of that there. So where you see the steel beams here, there'll be decking on top of that. So that's right around there is a deck. Eventually there'll be a balustrade between these posts. So the deck goes right around. And then, so we've got these top light windows and a 3.7 metre high ceiling, I think, in here. So you'll get a really nice quality of light with the morning sun coming in. So we've purposely avoided having that on this side because we want to invite the sun in the morning from the east, and then we want to try and most of the time keep it out from the west, and down the far end here on the west side is the master bedroom suite. So that's got the big overhang, but it's also got windows that have shutters attached to them, and that's part of what the window supplier supplies. And so you can either have a external roller blind, or a shutter. And that's really good for both shade, protection from overheating, although I don't think that will be a problem in this house, but because of the overhang, but also for privacy. And in Europe, shutters are quite common, and for security too. So it's just something that's not really seen in New Zealand, but it's pretty common overseas, the window shutters. So those are either controlled via a switch or via an app on your phone. And they can be automated so that at certain times of the day or with a light sensor or based on what the temperature is out at the time, they can be automated. So that's cool. When you're up on a hill, sometimes the horizontal shading protection isn't quite enough. You might need some vertical shading as well because you get the last of the sun when you're on a hill site. So those are kind of some of the key things that we think about. Obviously, the number one thing is the thermal envelope and what we call the thermal envelope, which is all of the building structure, floor, walls, roof, windows, how that's working and making a really good job of that, so that there's minimal energy required for heating or cooling. So we're targeting a really high level of thermal performance. And it's not just about more insulation or thicker walls or better windows. The other aspects that are really important that people often don't think about is the air tightness, which I mentioned briefly, and also thermal bridging. So in this house, Dan might talk a little bit about how we're trying to, some of the details, how we're trying to avoid thermal bridging wherever possible. So those are the things that kind of people miss. And I think because our building code is so poor, people really need to do their own research. And a lot of people do through the Superhome movement. So Superhome movement's now been around for almost 10 years. So people have the opportunity to learn about what a decent home is. Other countries, they just get a decent home anyway because that's where their standards are at. But in New Zealand, that's not the case. So people have to do their own research if they want something that's going to perform and be healthy. So I do see a lot of people, like on the recent tours, someone said to me, I've done all these things, and they sort of had a list of things: better windows, heating, underfloor heating, ventilation, sort of rattled off a whole list of things that they'd done, and they were all good things, and it all made sense. And they said to me, but our house still has a really big power bill, so what did we do wrong? And I said, well, did you think about air tightness? No. Did you think about thermal bridging? What's that? So the danger is just, I think that the best thing is to get the right people involved, the right designer, the right builder. And there's only a small niche, probably about 5% of architects that are actually thinking about the Superhome principles. There's some good builders too. Dan, obviously, is a good builder who's been involved in the Superhome movement from the early stages. There's other builders. Phil is another builder. He's had some homes on the last tours too. So, Another key element of this home, which Jeff might talk about a bit later, is Jeff from Sealco over there, hiding around the corner, is the warm roof. So this roof here, it's a structural mass timber panel, so it's XLAM, which is cross-laminated timber. So that's, if you look around the outside, you might see how it goes together. But so that's about 160 thick, yeah. And then on top of that, so that's flat, and then on top of that, there is insulation, rigid insulation that is creating the fall of the roof. So there's a 1 degree pitch. Is that right, Jeff? 1 degree? Yeah. Yeah. 1.5? Yeah. So that starts really sort of almost nothing at the front and then goes up where you don't need the insulation, where the overhang is, and then goes up to, it gets quite thick at the middle of the roof. So it's sort of a two-tiered roof too. So we can get these clerestory windows and get that nice quality of light. So on top of we sort of reverse engineered that a little bit to get the cost down. So we used the majority of the insulation, the thickness, the build-up is EPS, which is expanded polystyrene, which is, Jeff will probably go through the details, so I probably don't need to. And then we put a thin layer of PIR on the top of it, which is the more expensive material, because the membrane that goes on top of that can't be glued to the XPS. So I'm a real fan of these warm roofs because it means you've got continuous insulation, you've got no thermal bridges, whereas normally conventionally you'd have insulation in between rafters or in between trusses and that sort of thing. You have these gaps where you've got no insulation. So that's a great idea. It's not always a membrane either. You could have a metal roof, you could have shingles, tiles, whatever roofing material, and still have the continuous insulation. You can also retrofit that to an existing home as well. So the challenge with this sort of roof is that where do you put the services? So these purple wires are the electrical circuits for the lighting. There's slightly different wiring because it's got to be the right PVC sheathing so it doesn't react with the polystyrene insulation. But that noise won't be a problem once the triple glazing's installed. So the issue is where do you put the ducts for the ventilation, because all super homes need a whole home balanced energy recovery ventilation system. And in this house, the most of them are run in the underneath the mid floor here. So this floor is speed floor. Dan will talk about that. And then there's a ceiling space. But the speed floor it has holes in the structure, so it allows for those services to be run through underneath here. And then we get up into this space here where we can have some dropped ceilings too. So some of the bedrooms have lower ceilings. That's the master bedroom down there. I think it's 2.5. There's a really cool bedroom over here that sort of half of it is high ceiling and half of it is lower. And it's got a really nice corner window that'll have a nice, get the morning sun and then have a nice view of the ocean and watch the ships coming in. And then there's an office, it could be a bedroom, but we're calling it a multi-use room. It'll be the owners will use it as the office. And then down below, the plans are actually on the wall around there that you can look at later, but down below we've got basically a self-contained dwelling, which this could be a multi-generational home where that could be closed off and it could actually be used by anybody and accessed via the lower level. And then the other thing downstairs is the wine cellar. So so there's a door that you could lock and then just to keep those people away from the wine. But the wine cellar is thermally isolated from the house. So we've actually got concrete walls and a gap. I think there's a plywood sheet covering it so you can't go in there. Or maybe there's wine in there and they don't want it drunken. But so that's great because it means you want that wine to be at the ambient temperature and connected to the ground basically. So the ground temperature might be sort of 10 or 12 degrees. Perfect for wine. If that actually had a thermal link bridging to the nice warm house, then that would mean that it would be getting too warm. So we sort of wanted the opposite there. We wanted to keep that cool. So I think we had a thermal break in the concrete and then there was fiberglass instead of steel to eliminate thermal bridging because steel is really a really good conductor. It's about 54 times as conductive as concrete, so just even a little steel rod is going to have a big difference. So the windows, these are Kaufman windows, so they're imported from Poland. And Poland make a lot of windows. But yeah, so we found those, Dan and I did this project here, the Big Cottage, which was on the Open Christchurch Festival of Architecture earlier this year, and it was on a previous Superhome tour. And that's the first house we used these Kaufman windows. So lots of people came and looked at that house and commented on what beautiful timber windows they were. And I didn't say anything. I was just like watching people. And then afterwards, I answered questions. And I don't know if we've got a sample window. I think it's here actually. Oh, no. Yeah, yeah. We've got the windows there. Oh, yeah, sure. So afterwards, I when they agreed that they were beautiful timber windows, I showed them this and said, this is actually what the windows are. Because the veneer has got so good that people just, it's totally believable. So I'm normally not a fan of things that are fake, that pretend to be something else, but that one there is great. And probably one of the main reasons I like it is it's half the price of timber windows. Timber windows are beautiful, but they're double the price of these windows. And so these come to New Zealand in a container. They already have the glass in them. Triple glazed is standard. So Europe, it's standard to do triple glazing. So you're not paying a premium for that. So here in New Zealand, it might be like 40, 50% more for triple glazing. Might be going down as time goes by because it's getting more common, but it's only like 3 years ago that became an option locally. But so these can be landed in New Zealand for roughly about the same price as double glazed normal aluminium windows and locally provided ones. Yeah, the standard is with the European windows. There's a couple that are installed. You'll be able to have a play with them, but the standard is tilt and turn, and that just means that it's going to be really well sealed too, because it's got this sort of mechanism where you've got multi-point. You've got about 6 points where it latches, so it sort of sucks the window in, and it's got three different seals on it. So it's incredibly well sealed and airtight. So the thing about New Zealand windows, they are getting better, but they've been hopelessly air leaky. Particularly the sliding doors. You could put better glass in it, but it's still around the frame. It's going to be really leaky, and that has a big influence on the performance. As does it, air tightness for the whole house. But the windows was a big air leak. So the European windows have what's called lift and slide doors. So you can have big sliding doors and they can be sealed really airtight too. So they have a big handle on them, big lever handle, and you turn it and it raises the door up a couple of millimeters. So it's even a big heavy unit with triple glazing, it can slide quite easily. And then when you close it, you pull the lever around and it just sucks down onto the floor and seals all around. So they're called lift and slide. The houses it's been an interesting sort of journey, and just sort of as these new products become available, houses get better and better and more airtight. And New Zealand is always playing catch up because we're a couple of decades behind the rest of the world. Our building code is at least 2 decades behind in terms of the thermal performance and the things that we talk about with Superhome movement. And so that's one of the main reasons that we started the Superhome movement, to make people aware of where their building code's at and why we need to do better. So for me, one of the main reasons is health. So a lot of our clients, and Andrew and Lauren, they're part of the medical fraternity too. So I think they're radiologists. So there's a lot of doctors and nurses and medical people that get us to design houses for them, because they're acutely aware of how New Zealand's poor housing is affecting the health of the nation. And it's particularly bad for young kids and the elderly, who are more susceptible. But we've got the worst asthma rate in the world, and my kids went through that when we had to move out of our house after the earthquake. So that's sort of part of my drive for doing the Superhome too. So the oldest boy got bad asthma, and the he was allergic to mould, so the trigger for that was damp, mouldy homes. And then, I became aware that that's how half the population is living, and there's a lot of research about the effects of that, but unfortunately that hasn't led to change in our building standards. So we thought, we're not going to wait for the building code to change, we'll just get in there and do the Superhome movement and try and create a bit of awareness and educate the homeowners as well as the industry about what we need to be doing. So the other one is we have a lot of people with accents, Dan? A lot of people from overseas that come to New Zealand and they've experienced good homes overseas, and they've either heard how subpar New Zealand homes are, or they've experienced them themselves when they've got here, and they just want something better than a building code standard New Zealand home. So that's probably all I'm going to talk about. I'll hand over to Dan to talk about the structure, and then do have a look around downstairs and everywhere. Have a look outside, and you can go wherever you like. Just be careful that you don't sort of step on anything dangerous, or watch your head on the scaffold too, because if you're wandering around there. But yeah, other than that, I think you can go wherever you like. Jeff will talk about the roof. But first, Dan will talk about from the builder's point of view, the construction.
As with all of our jobs, they start off with a structurally insulated foundation. So it's fully insulated from the ground, and no matter what methodology we use for doing foundations, we always insulate it. So whether it's a rib raft or a highly engineered one like this one, the lower floor and all the boundary concrete's actually got an additive in it to help prevent water ingress through the concrete as well as extra protection. So we use XPS and EPS as our main insulating products, and the lower slab is actually poured later as a topping slab. So that's the foundation is set, and then the walls go up. So then we, in order to have a fully insulated topping slab, we had to put insulation across the bottom and up the sides, put our mesh in, and put our hydronic underfloor pipes in, and then pour the concrete on top. So this one here is a bit different. It's more like a conventional slab, but because it is within the envelope, it's using a suspended concrete slab, which is, again, like Bob says, has got beams underneath which allows ventilation ducts to go through, and it's got mesh as well as our hydronics, which the manifolds are sitting over there for. So the exterior of the blocks you'll see behind you has fully insulated with polystyrene or XPS, depending on where it is. The timber that you see is fully thermally broken from the outside. It's got another layer of material in between the timber and the blocks, so that it minimises that thermal bridge. We always look for areas where that's going to happen and protect that as best we can. The walls we normally prefabricate off site, but because of the technicality of this job, and you can see the connections that we've had to make, we need a lot of open panels, so it didn't make sense to create a closed panel, then open it up again to put the mechanical fixing in. So that's the way we usually do our exterior walls. Like Bob says, PVC windows recessed into the wall. As you hear the road noise now, but once that windows are in, that'll go completely almost. Again, warm roof, which Jeff will talk about. We've also got our balanced ventilation system with heat recovery. So that's a normal thing we do, especially with airtight houses. It's a must. So if you can't live if you can't breathe, is the saying. So we always like to provide fresh air. Other than that, it's like Bob says, it's one of the best. It's the best on the best scale for the design guide or the certification process. So no matter what the budget is, I think we can always include a form of energy efficiency and high performance within any budget, really. So, Jeff, warm roof.
Good afternoon. I'm Jeff from a company called Sealco. We're a company that specialises in low slope architectural style roofing, mainly with membrane roofing. Because we work a lot with European and American manufacturers, we do a lot of these warm roof type situations, and it's quite simple for us because our systems allow for that. So it's really relieving to see the New Zealand market coming around to terms with the European style of building, a better way of building things. And of course, being involved with Bob and the team at the Superhome movement is really awesome to be able to work in with some like-minded people. So in a nutshell, Bob has given you a bit of a rundown of what a warm roof is. First of all, with heating and the thermal envelope, well, when you're going to lose most of your heat, you're going to lose it generally out your windows or your roof, because heat basically rises. So whatever doesn't go out the windows and walls is going to go up and out your roof. So the better way you can hold it into your the heat into your structure is obviously by creating a better insulation cover over your roof. Now, also, I mustn't forget also, is that it does work in the opposite direction as well. So if you've got a really hot day, it's going to help protect from the heat coming down through your roof. I don't know if anybody's ever been up in their corrugated iron ceiling when it's been a 30-degree day and you feel like you can fry an egg in there. It's essentially the same thing. It's by keeping the excess heat out of your building as well. So that's what these are designed for. So as Bob explained, X-Lam is basically a flat timber base and has really given us free range to create the falls and the direction of the flow of the water off the roof that we need to. So it is a very low pitch, but the idea of a low pitch is that you can keep your ceiling heights and the height of your build as high as you possibly can without having to worry about encroaching into recession planes, height planes, and all those sort of things. So we made the slope out of the polystyrene, the EPS polystyrene. It doesn't really show it much on here, but there is actually a slight slope on here. And as you're wandering around in the garage there, you'll see a whole bunch of polystyrene sheets in there. They're actually essentially placed down. If you have a look around here, you'll see this white plastic here, which is the vapor barrier. That's actually been put down on top of the X-Lam first, and then on the top of that we put our sloped boards going in all different directions. So what it does is it allows the water to slope off to the directions of where the outlets are. Now, because we use unfortunately we have to use solvent-based adhesives, but we use a very low VOC adhesive. It means we can't adhere our membranes direct to the polystyrene because basically the adhesive eats it. So we put a different layer in between the two, and this is what's called a polyiso. Polyisocyanoate is once again a European American product. It's a blown polyurethane, which is a more R value product per the density of the board. So it's a very high R value for the thickness of the board, and we adhere that to the top of the EPS, and then our membrane is adhered to the top of that. So what it does is that skin there on the polyiso gives us our surface that we need to adhere our membranes to, and then the membrane does all the waterproofing on top. Essentially, in a nutshell, that's it. There's different variations of the polyiso. There's a dense board up there and around the eaves areas and that sort of thing. We've got the main board here around the centre of the roof, and the polystyrene also has an R value in it, which is increasing the overall R value of the roof as well. So generally the R values these days are supposed to meet about 6.6. I'm quite confident we well exceed that. I don't know what the actual overall R value is, but that's the beauty of it. We talked about, Bob explained about the thermal bridging before, meaning that the whole roof is fully covered with the insulation. There's no thermal bridging through any framing or screws or steel or anything like that. And then And like I say, that stops the heat from escaping and stops too much heat from entering the structure. And then you've got your membrane waterproofing on top, which gives you your overall skin on the outside and the waterproofing protection.
Hanshu from Warm Stone Z. We do hydronic underfloor heating. We did this house both levels, ground floor and upstairs, as well as the hot water heating using the same heat pump. So with Bob design, Dan building, and the warm roof, we've got a very well insulated house already. So then what you need to think about is what kind of heating you need. Underfloor heating is much better than air ducted solution in this space in particular. The roof height is here. Any kind of ducted system you put into the space is going to heat the roof first. You have a warm roof to capture that heat, but by the time that hot air coming down to where we're comfortable, there's a lot of energy sitting up there that we're not really utilizing. So when you have underfloor heating, there's water pipe going through the foundation. We're using heat pump technology. It's very efficient to run. Then heat pump heats the water, bring that into the floor, circulates every part of the house. Sunny day here, very comfortable. The bedroom down there will be cold. How do we heat that? Because the water in the floor goes into that room, gives the heat to the room. So that's the way of whole home heated solution with underfloor heating. Very different living style. Europeans are quite used to it. New Zealanders still very much a single room heated space. Bedrooms are cold, bathrooms cold. You can have under tile, electric underfloor, very expensive to run. The luxurious feeling is the same, but you don't have that in your bedroom. Why do we build a house when we're not trying to heat every room? The cost comes into it. So the heat pump technology solves that issue on the basis of we have a good design, well-insulated house. Somebody actually just asked me before, how much does the system cost to run? It actually depends on how well the house is insulated, how much heating that's going to be required by the house, or by the customer. If you want 18 degree, you want 23 degree, cost different. If your house loses a lot of heat in winter, we're going to put more heat into it. A heating solution is providing the heat, but we can't really guarantee how much heating you will need. But with the same comfort, underfloor heating gives you a lot more even heat throughout all year round. In winter time, you don't really think about when you turn on the heating solution because the heat's there already, not just in the air. It's everything that you touch, all the floor, toilet seat, whiteware, everything in the house is gonna be the temperature you're comfortable with. People don't really feel that until you're actually living a house like that. Then you go into your friend's house, you'll be like, oh, next summer, we'll go to yours. Next winter, just come to mine. That's kind of the concept we have when you have a whole home heated solution. That's kind of what I've got to say, but yeah, happy to talk to you. So the concept is quite simple and the installation is also very simple. Pipes into the foundation, concrete floor, heat pump outside. We don't really show people, so that's always hidden, but you'll see some pipe works coming out from the floor. That's what it is. You don't really see them, and then it makes no noise when that goes around. There's no air blowing, and then there's a centralized controller on the wall that basically thermostatically control. You don't need to know the temperature, or you don't need to go up and down or control them or not. But saying that, these days everything is on the app. You could turn it on, you could turn it down if you're going away for a while. If the house is maintaining the heat well, you set the house to 16 degree, then you go away for a week or two, come back, turn it to 22. Doesn't take a lot to heat up. But if you let the house to cool down to 13, then takes a bit time to come back. Yeah. Cool?
What about repairs?
Repairs about the floor.
And the piping. So if it's built into the concrete, how do you do it?
So it's actually built within the structure. We normally place it underneath the mesh, sometimes with the mesh on top. The underfloor heating, you might have heard underfloor heating needs repairing. Most of the case is electric on the top. The surface cracking. Because the pipe is already deep in the concrete, By the time you actually break the concrete, the mesh is actually protecting the structure. If you break that, the house is going to be in risk more than just the pipe. During the building process, there will be times maybe plumbers hit the pipe. We pressurize the whole system during the build. So if there's something goes wrong, we know it, we come back, repair that. And because it's normally happening before the house all get closed down, we will be able to fix that without you actually noticing it. So it's repairable, yeah. But once the house is built, nobody goes around drill holes into the floor. And then if there was any leak or anything, we would know that because the system is pressurized. Yeah, cool. So it's quite low maintenance. We kind of suggest people every 2 years will come around, check it. If nothing goes wrong, that system just carries on. Because heat pump technology, there's not much to service on, really. Yeah. Cool.
Do you know how powerful that heat pump would be to run a house this size?
Powerful.
Yeah.
The COP of the heat pump is quite universal these days, so they all competing with each other. 5 years ago, 1 to 4 is common COP. These days, 1 to 5. Obviously, in a certain condition. So 1 kilowatt electricity in, 5 kilowatt out. That's the same as a ducted heat pump. Heat pump is a heat pump to an extent, but we're using water makes it more efficient to capture the heat and contain the heat. Yeah. So 1 to 5, you can't really get better way to heat or more cost-effective way to heat compared to any other way. And also can be reversed for cooling.
Does it do the hot water as well?
Yeah, it can be. It can be done. This house is done that way. So reverse to cooling is another thing that heat pump can do. You can do underfloor cooling, and then you can also use what we call fan coil, potentially push cool air through using the same heat pump. Hot water heating is another sort of a side benefit when you use hot water heat pump because they're heating water anyway. But hot water cylinder has a high temperature need, maybe 55, 60 degree. Underfloor you're sitting around 30 degree, 35 degree. But the same heat pump can do both. Application are different in different houses. Yeah, so we'll have to look at the house.